Hey guys, here's a video about special right triangles. You might recall these from geometry. You are going to encounter special right triangles as you work with trigonometry all the time. So we definitely want to review our special right triangles. There are two right triangles that we consider special. There are infinitely many kinds of right triangles and um, with all sorts of different angle measures. But the two that we will be focusing on today are what we call the 45 45 90 and the 30 60 90 triangle. So what we notice about a 45 45 90 triangle is that the sides are always in the same ratio. So we see here that we learn in geometry that when you have a triangle where two legs are the same or two angles are the same, then that means that their corresponding legs are also the same. So this is an isosceles right triangle. And what we notice with any 45, 45, 90 is whatever the length of the leg is, in this case x, you can simply take that number and multiply it by the square root of 2 to obtain your hypotenuse. So it's kind of a little bit of a shortcut, if you will, to finding a missing side. And that's what we're going to be focusing on today. So here are a few things that we notice. First of all, the legs are congruent. Now let me reiterate what I mean by legs. In a 90-degree angle, in a right triangle rather, the hypotenuse, remember, is always the side across from the right angle. So the hypotenuse is this side here, which we have labeled with a length of x square roots of 2. The two sides that are not the hypotenuse are called the legs of the right triangle. And we know in a 45, 45, 90, the legs will be congruent. Now, let's say you know the legs, but you want to find the hypotenuse. Well, here's your rule. You simply take the length of your leg, you multiply it times the square root of 2, and there is the length of your hypotenuse. Now, if you're going to go backwards, let's say you know the hypotenuse and you're trying to find the length of a leg, well, then you're simply going to do the opposite of that, which is divide by the square root of 2. So let's say, for example, that your legs are 15 feet. Well, then your hypotenuse would be 15 times the square root of 2. Let's look at some other examples. All right, so we're going to find the missing sides, and here's an important note here. It says leave your answers in simplest radical form. So we're going to talk about what that means. So let's take a look at this first example. We have a triangle. We know that this red symbol here means that we have a 90-degree angle. We're told that this angle is 45 degrees. Well, every triangle has three angles that add up to 180 degrees. So if you were to add 90 and 45, you would get 135. When you subtract that from 180, that tells you this angle is 45 degrees. So it wasn't necessary to tell us all three angles. If this is 90 and this is 45, this one must also be 45 degrees. We know that, first of all, in a 45, 45, 90, the legs are congruent. Well, let's talk about what the legs are. And it might be helpful to first point out what the hypotenuse of this triangle is. The hypotenuse of this triangle is the side labeled A, because that is the side opposite the 90-degree angle. The legs are this side labeled 2 square roots of 2 and B. And the first thing that we noted up here was that the legs are congruent. So you might want to pause, take a moment to either take a picture of this situation here or write this down, because this would be a really good reference for you to use as you work through your assignments. So I see that the legs are congruent. Well, the legs are 2 square roots of 2 and b. So that tells me right away that b is also 2 square roots of 2. So my next task is to find a, which is the hypotenuse. I know the leg, and I'm trying to find the hypotenuse. Up here, if we want to find the hypotenuse, we're going to take the leg and multiply it by the square root of 2. Okay, so we're going to take 2 square roots of 2. We're going to multiply it times the square root of 2. And when you multiply 2 square roots of 2 times the square root of 2, you get 2 square roots of 4 because you multiply the 2's under the radical sign. Well, the square root of 4 is just 2. So really, this is just 2 times 2, or 4. All right, let's look at example number 2. This time, I have a right triangle, 45 and 90. Once again, this angle has to be 45 degrees, since the 3 angles of a triangle must add up to 180. The side that I know is the hypotenuse. X and Y will be the legs. Now I know the legs are congruent, so when I find X, I will have also found Y because they are congruent. They are the same measure. So let's review, how do we go from the hypotenuse to the leg? In other words, how do I find the length of a leg if I know the hypotenuse? Well, up here it says the hypotenuse divided by the square root of 2 is equal to the leg. So I'm going to take 4 and divide it by the square root of 2. So let's walk through this one step at a time. 4 divided by the square root of 2. You really can't divide that. You can't divide a rational number and an irrational number. Either both numbers have to be rational or they both have to be radicals. So I really can't divide this, at least not nicely. So what we do here has to do with this, where it says leave your answers in simplest radical form. You might recall that it's considered improper to leave a radical in the denominator, and there's actually a very simple fix for that. You could simply take your square root and you want to multiply by something that is going to take away the radical. And if I simply multiply by another square root of 2, that gives me the square root of 4, which is a nice rational number of 2. So I have that indicated in green, showing that whatever I multiply the denominator by, I'm also going to multiply the numerator by that same thing. Now, if you want additional practice with rationalizing the denominator of a fraction, you could simply Google that, or we could talk about that at a later time. So I'm multiplying 4 times the square root of 2 in the numerator, 2 times the square root of 2 in the denominator to get the square root of 4. And once again, the square root of 4 is 2. Well, now I have something, first of all, my denominator is nice and rational. Notice now at this stage, there is no radical sign in the denominator. That's the point of rationalizing the denominator. And now the 4 and the 2 that are not under the radical sign can actually do math together. This 4 and this 2 get to divide. 4 divided by 2 is 2, and then the radical 2 is just hanging on. So, whew, that was a lot. So sometimes these problems can be very simple, but when you have to rationalize your denominator, it does add an extra step in there, and that can get a little bit confusing. 2 square roots of 2, it should be noticed, is mathematically equivalent to 4 divided by the square root of 2. They are the same number. All we've done is changed the form. It looks much nicer like this. Well, the good news is once we found X, we know Y is the same thing. And so we can simply mimic the answer. Y is also 2 square roots of 2. So once again, it is a simple concept, but even though it can be complicated by the radicals, The three things that we need to remember about a 45, 45, 90 is that the legs, the two sides that are not the hypotenuse, are congruent or the same measure. If you need to know the hypotenuse, simply take the leg and multiply it by the square root of 2. If you need to know the leg, but you have the hypotenuse, you simply divide by the square root of 2. It's easy for me to remember because I know that the hypotenuse is the longer side, so I know I'm going to multiply by something if that's what I'm trying to find. I know the leg is smaller than the hypotenuse, so I know I must divide if I'm trying to find the length of the leg. Let's look at a couple more examples. If you would like to, you could pause this video and attempt to answer questions 3 and 4. I know they look a little bit complicated perhaps with the radical signs, but give it a try and see what you can come up with. Okay, so hopefully you had a chance to pause the video and give this a try. Let's take a look at example 3. In example 3, I have, again, a 45, 45, 90 triangle. Notice that the hypotenuse is labeled with X. I do not know the hypotenuse. But remember what I do know. The legs of a 45, 45, 90 are the same. So it would be nice and easy for me to actually find Y first. So let me see if I can do that. Yeah, Y, I can just say, well, that has to be 3 square roots of 2 divided by 2 because I know that these two sides, these two legs are the same. Okay, next I need to find X. Well, X is the hypotenuse, and you might recall from the notes earlier, the hypotenuse is bigger, so I'm going to multiply by the square root of 2. So I'm going to take this 3 square roots of 2 over 2, and I'm going to multiply by the square root of 2. All right, and here's the math involved. Okay, so I've got 3 square roots of 2 divided by 2, and then I'm multiplying by a square root of 2. Now, when you have a fraction and you're multiplying by something that's not a fraction, remember you're just going to think about this as having a denominator of 1. So really this square root of 2 multiplies only with the numerator. So 3 square roots of 2 times the square root of 2, well, the 2's under the radical multiply together, leaving me with 3 square roots of 4. This you can think about as having a denominator of 1, and 2 times 1 is 2. A common mistake that students make is to try to multiply this thing that's not a fraction with both the numerator and the denominator, but you only multiply this with the numerator. Now this time we don't have to worry about the rationalizing of the denominator. My denominator is quite lovely. It's simply 2. But I can do a little simplifying because guess what? The square root of 4, well, that's just 2. So this really just says 3 times 2 over 2, which is 6 divided by 2, or 3. Now, if you did not get a chance to pause for question 4, or maybe you didn't, or maybe you tried and now you have a little better idea, see if you can attempt question 4. So hopefully, at this point, you've answered question 4. Let's take a look. We have our 45, 45, 90. We have our hypotenuse that is missing. This question is very similar to number 3. The steps will be the same. We know that the legs will be congruent. So Y is going to be the same as this other leg, 3 square roots of 2. We know that if you have a leg, you know the leg, and you're trying to find the hypotenuse, which is larger, you're going to multiply by the square root of 2. So I'm just going to take 3 square roots of 2, and I'm going to multiply by the square root of 2. Again, the radicals get to do math together, so the 2's get to multiply. But the square root of 4 is just 2, and 3 times 2 is 6. All right, so that is an example of how you can find missing sides of a 45, 45, 90 triangle. Let's take a look at the next special right triangle, the 30, 60, 90. The 30, 60, 90 is a little more complicated because we have 3 sides that are all different lengths. Now, one thing about geometry that I would like to remind you about is you can judge the order of the side lengths by the order of the angles. Here's what I mean by that. We know, for example, that your longest side of your triangle is going to be opposite your right angle. So this 2x represents the longest side of your triangle. But here's what you might not remember. If you look at the 3 angles, the 30-degree angle is the smallest angle. And if you just look opposite your 30-degree angle, you're going to find your shortest side. So this side that's labeled X, we're going to call that the short leg. Remember that the sides that are not the hypotenuse are called the legs, even though in this triangle, the legs are not the same length. The side opposite the 60-degree angle is going to be longer than the side opposite the 30-degree angle. So we're going to call this the long leg. So just to review, in a 30, 60, 90 triangle, you have a short leg, you have a long leg, and then you have the hypotenuse, which is the longest side of all. Now, this is the ratio that for any 30, 60, 90 right triangle. Whatever the length of the short leg is, you can double that, and that would be the length of your hypotenuse. So for example, let's say that your short leg is 5. That means your hypotenuse would be 2 times 5, or 10. If x is 5, then your long leg is 5 times the square root of 3. Now, it's very important to note that in a 30, 60, 90, the square root that you are working with is the square root of 3. In the 45, 45, 90, it was the square root of 2. So don't get that confused. So if you haven't already, you might want to pause, take a picture of this 30, 60, 90 triangle situation and the notes we have here, or write this down. This is invaluable for you as long as you remember which leg is the short leg, which is the one opposite your smallest angle. The long leg is opposite your 60-degree angle. And then, of course, your hypotenuse is the longest leg of all. So you know that 30, 60, 90 is order from small, medium, large. And your sides are in order from short leg, long leg, and hypotenuse. So we know that if, once again, from the short leg to the hypotenuse, you're going to multiply by 2. And if you're going the opposite way, if you need to know the short leg and you have the hypotenuse, you can take this number and divide it by 2. You can also do math between these two guys, the short leg and the long leg. You can take your short leg and multiply it by the square root of 3, and that gives you your long leg. Or you can take your long leg and divide it by the square root of 3 to get your short leg. It's kind of interesting to note here that we don't have a direct, at least in my notes, I didn't put a direct link between the hypotenuse and the long leg. I usually like to always go back to the short leg first before I figure out anything else if I don't know that. So my first order of business is if I don't know the short leg, that's what I want to know first, because everything else is based upon that. Look at this problem. This side is x. I need to know x before I can figure out what 2 times x is. I need to know x before I can figure out what x times the square root of 3 is. So always try to find your short leg first, even if that's not ultimately what you're looking for in the problem. Okay? Let's look at some examples. All right, same instructions. We're going to find the missing sides, and we're going to leave our answers in simplest radical form. Remember, that simply means that if we have a fraction and there's a radical in the denominator, we're going to multiply by something that will eliminate that. So let's see what we have here. Notice that once again, they're being a little elusive. We know that we have a 90-degree angle here in red. We know we have a 60-degree angle. 90 plus 60 is 150. The 3 angles of a triangle must add to 180 degrees, and 180 minus 150 is 30. So they don't have to tell me that this missing angle is 30. It has to be 30. And so that's why they didn't bother to write that part. This is a 30, 60, 90 triangle. And I know one of the sides. It's important to know, what side is that? Is that the hypotenuse? Is that the short leg? Is that the long leg? Let's figure this out. Well, notice that this side that I'm given, that's 8 units long, is opposite the 30-degree angle. Well, since 30 degrees is my smallest angle, this is my shortest side. Okay? So I can find these. And remember, I said I always want to know the short side first. So in this problem, I'm in a good shape. I already know the short leg. So let's go back and see what I can find out. I'm going to take the short leg times 2, and that's going to equal the hypotenuse. I'm going to take the short leg times the square root of 3, and that's going to equal my long leg. All right, so let's take a look. So which one is my hypotenuse? Well, it's the one opposite the 90-degree angle. So I'm going to do 8 times 2, and that is 16. All right? So I've found the hypotenuse, U. Now to find the long leg, you take your short leg times the square root of 3. So 8 times the square root of 3. Well, lovely. 8 times the square root of 3 is just 8 square roots of 3. I'm fortunate in this problem that there are no fractions and there's no radical to simplify, so I'm in good shape here. All right, let's take a look at question number 10. In question number 10, I'm given this side here that is measured 8 square roots of 5. Again, I need to know, what side is this that I'm given? Is it the short leg? Is it the long leg? Is it the hypotenuse? That is very important to note, and you might even want to write on here what this is. I notice that this leg is opposite the 90-degree angle, so it is the longest side. This is the hypotenuse. And I need to find the short leg and the long leg. This is the 30-degree angle over here on the right, which means that Y is my short leg and X is my long leg. And this picture is drawn to scale pretty much, so it's easy to recognize. Sometimes it's not so easy. So you do have to pay attention to the angles. The side across from 30 is your short side. Remember, I said that's the one I want to find first. I know X comes before Y in the alphabet, but it's going to be much easier for me to start by finding the short leg first. So let's go back and look. If I want to find the short leg and I know the hypotenuse, I need to take the hypotenuse and divide it by 2, and that will equal the short leg. Well, that seems easy enough. So Y is simply going to be 8 divided by 8 square roots of 5 divided by 2. Well, the numbers that are not under the radical are the ones that get to do math together. So 8 divided by 2 is 4. and y is 4 square roots of 5. So now I know the hypotenuse and I know the short leg. The only thing remaining is to find the long leg. So let's see how I can find the long leg. To find the long leg, I'm going to take the short leg times the square root of 3. Well, the short leg is what I just found, 4 square roots of 5. So I'm going to take 4 square roots of 5 and multiply it by the square root of 3. And it looks like I didn't finish this problem, but that's okay. Let's do this together. Let me make this a little bit bigger. Now, when I multiply 4 square roots of 5 times the square root of 3, the 5 and the 3 get to do math together. And so, let me find my equation. Let me do this. Equals. I'll figure this out. Well, it's going to be 4 times the square root of 15. I'm not sure why I can't get that to work, but hopefully that makes sense to you. It'll just be 4 times the square root of 15. Now, if you can simplify the square root of 15, you should do that. But we know that 15 is not a perfect square. It also does not have a perfect square that divides evenly into it. So we would leave this answer as 4 times the square root of 15. Now, if you feel comfortable, pause the video and see if you can answer number 11 and or number 12, and then come back here. All right, let's see how you've done. On question number 11, we have our 30, 60, 90 triangle. The 30-degree angle is up here in this corner, in the top corner. If I travel across the triangle, then I'm going to get to this side. Why? This is the shortest, the short leg represented by Y. What I know is this side, which is the long leg. I also do not know the hypotenuse. Excuse me. Now remember what I said. If the first thing I want to find is the short leg. I know the long leg. I need to find the short leg. So what was that rule? If I want to find the short leg, given the long leg, I'm going to take the long leg and divide it by the square root of 3, and that's going to give me my short leg. So I'm going to take the long leg, which is 5 square roots of 3. I'm going to divide it by the square root of 3. The square roots of 3 cancel out, if you will, and so we're simply left with 5 for the Y value, or the short leg. Now the hypotenuse, if you'll recall, can be found by taking the short leg and multiplying by 2. So we're simply going to take 5 and multiply it by 2, and we get 10. All right, if you haven't already tried question 12, go ahead and pause this video, see if you can answer question 12, and then come back to me. All right, let's take a look at question 12. What are we given? We are given the hypotenuse of this 30, 60, 90 triangle. What I don't know are the legs. I don't know the short leg, which is this one here represented by Y. I also don't know the long leg, which is represented by X. Which leg do I need to find first, the short leg or the long leg? Hopefully you answered the short leg. I know X comes before Y in the alphabet, but it would be much easier to go ahead and find Y, the short leg, first. So what is the rule if you know the hypotenuse and you're trying to find the short leg? Well, the hypotenuse divided by 2 is equal to the short leg. Easy enough. We simply need to take 10 and divide it by 2. Yay. Now that we know the short leg, we need to find the long leg, which is x. Well, to find the long leg, you're going to take the short leg times the square root of 3. All right, so we multiply the short leg, which is 5, times the square root of 3. Well, 5 square roots of 3, 5 times the square root of 3 is just 5 square roots of 3. And that concludes your video for special right triangles. Good luck, guys.